Hello friends, so today we are going to discuss about reverse dial indicator alignment method. I am Harshad Patel. I am CMRP certified rotating equipment reliability engineer. Currently I am working with Saudi Aramco and supporting their reliability unit. I have experience of 16 years and I have worked many petrochemical sectors and industries like Reliance Industries Limited, Opal and SR Oil Limited. I have seen on site that people are very reluctant and they don't have exact practical knowledge regarding reverse dial indicator method. If their bosses or their engineers saying that we have to perform alignment by reverse dial, then they have to just imagine in their mind. Some are just witness the readings. They don't know how these reading to be interpreted, and many engineers I have seen that they just follow the OEM only. So here I will throw some lights on how this element method perform on site, exactly what points you should have to keep in mind and what you should have to imagine. So let's go that point one by one. Uh, Here you can see I have here I 1 minute. Take a laser. So here you can see I have draw two shaft with the coupling faces. Uh, First point you have to uh, keep in mind that you have to keep a fixed machine on your left side. When you are on site, you must keep a fixed machine at your left side and a movable machine at your right side. Let's write here. This is the fixed machine and this is the movable machine. So always keep in mind because there are formulas, but when you keep fix and when you interchange fix and movable with each other, the formula will give you the wrong result and you cannot interpret that. So many people do these type of mistakes, so keep in mind. uh, Another point, you have to mark these 12 uh, 3 6 point on the flanges. There are two flanges. One is fixed machine like pump, turbine, compressor, gearbox. Another is a movable machine like motor, gearbox, compressor, like that. So you have to mark 12, 3, 6, and 9. Third important point is you have to rotate the machine only and only clockwise because we know we perform element during continuous shift. So when you get handover from your next shift or you give handover to the next shift, you must inform them that they should rotate the machine in a clockwise direction. Otherwise, when you receive the uh, handover, you have to perform again the element method to verify the readings. So don't take shortcuts, always rotate machine on clockwise direction. Another point is people take shortcuts that because this is a very fast and practical method, reverse dial indicator. People first correct with a horizontal plane and then they go for shim correction. But these shortcuts will cost you more time and more energy. So don't go for that shortcut. First, always try to correct vertical a plane and then go for a horizontal plane. Uh, yes, the next point is you when you do correction on vertical plane, you must take consider of 12 and 6th point reading only. Do not consider 3 and 9. These 3 and 9 reading are only for our continuity check or element rule are following or not. But for calculation, you should not confuse with 3 and ninth position reading. Uh, they all these four are to check only zero check. So when you do vertical check, you must consider only 12th and 6th position reading only, because when when your pointer is on 12th position, one pointer will be on 6th position. One more confusion people do, that they mention like motor to gearbox reading or gearbox to motor reading. Don't do that. Always mention dial on the fixed machine, or always mention dial on the movable machine. Like dial on the turbine, you can mention dial on the gearbox, dial on the compressor, dial on the pump. Or you can mention here dial on the motor, dial on the gearbox, dial on the compressor. So that by that description you get easy idea that reading about that reading. Okay. Now there are so many formulas available on the internet, on the Google, on the YouTube. You just follow that formula with this setup only, so that you get correction readings. And next slide we will show how the graphical method works, so that whenever you use formula, you can verify with this graphical method. So as we have discussed, this is set up for a vertical correction. And if I get my pointer is here, one pointer, dial indicator is here. So when you rotate clockwise direction, uh, so both the shaft will rotate clockwise. Here also it will rotate clockwise. Okay. So you will get some reading like 36 division, 64 division. So how you plot? Just draw one x-axis and y-axis here like this. And this is upper side is a plus positive area, and bottom side is a negative area. So how you plot? You have to divide these division. So that for example 36 means 18 division you have to plot here, like this is the fixed machine foot. This is a movable machine for movable machine distance. This is a front or D side foot distance F1, and this is the F2. It is ND side or far end side foot distance. You have to scale it accordingly. So when you plot a 36 division divided by 2, it will be here. 64 division is equal to 32 division. It will be here nearby. So you just have to connect these two dots and you will get some correction readings. So this much amount division you have to move to superimpose this red line with this green line. So this is our correction as per the graphical method. So you can verify with this with our formula. Here it is showing you have to remove some shims to get red line superimposed on the green line. So this is a vertical correction. It is very simple, but people get confused in a horizontal correction. As we have mentioned here, our 12th position. Uh, Let me draw 12 here also, 12 here. What position? Here is 3. What position here, 9 or 3? It will be 3. Do not confuse. Do not write here 9. People get confused. Let me explain once I write this. Okay. Okay. This is 9. And here this is 9. So let's go back again. Here you can see here 3 and 3 are matching with each other. Here 9 and 9 matching with each other. But when you write here your element readings, you cannot simply write like here 3 and here 3, because you imagine you are moving clockwise, right? When you stand here, motor and side, and viewing the pump or compressor or gearbox or turbine, you are at a motor side. So these plane also move clockwise. Here you can see this plane move clockwise when you are viewing uh, this side, okay? But this plane move anti-clockwise, right? When you move here, this is also moving clockwise, but clockwise when you see from front, it will show anti-clock, right? When you see from motor, this fixed foot end will move clockwise, but when you come pump side and will see this front face, it will move anti-clockwise. But we require both the reading clockwise, or we must require reading in the viewpoint of motor only. So you practice this imagination. So when you plot here the clockwise movement of the both the plane, you will get the same reading, like 12th position here. This is the 12th position. This is third. This is sixth. This is same like 12, 6 and 8. Okay. Uh, so let me erase this all. Right. So, sorry, I have to do it again. This is our sixth position. So, simple. You don't have to consider 12th and 6th position reading. You just have to consider this third position and ninth position reading only. Likewise here. So when you keep a dial here on a third position, one dial will be here at a ninth position. So when you rotate clockwise, you will get some reading like 20 division. Here you get, here we get 40 division. Now, simplest method is just view these on a top side. You try imaging and let me know if you get a point or not. Just try to imagine that these reading are the top side. Okay, so let's move here on a graphical method. This is plus, this is minus. We get 20 division at ninth. So here our fixed motor 420, it means 10th division here, and 40 division at third position, it means here somewhere as per scale. So 20 division will be here. So we just have to move this. If this reading is minus, if this reading is minus, then so if this reading is minus, then 1 point, 10 point is here, and 20 point is nearly about here. So you just have to draw a line like this. And this is our correction. This distance is our correction, right? So here, if we consider this yellow line like this, you have to move the machine left or right, or towards third position or towards ninth division. So if we consider this plus reading 20 and 40, and it's showing this much amount machine you have to move, right? So let's understand from this graph. Let me erase all these things. Okay. So let's draw again. As per the graph, this is our, and this is the red line, and this is this line we have to move in horizontal direction. So if this plane is a top side, top side, and let's draw, this is the motor. Okay, this is a shaft. So you have this leg here, one leg here, one leg is here, and just have to push towards ninth side. Okay, towards ninth side. If our reading is negative, we have to push from this way towards third side, right? So let me know in the comment that you get the point or not. Uh, let's connect with each other, and if you get some more idea, let me know. And if you require some more clarification, mention in the comment. I will try to I will try to again explain to you and subscribe the channel. Thank you. Thank you.